Hi, I'm John Janowick. I'm Executive Director of ECEDHA, and thank you for attending this industry spotlight. We're here with National Instruments, Mark Walters, Academic Product Manager for National Instruments. Mark?
Thank you. Good morning. My name is Mark Walters. I'm a Product Manager at National Instruments, and today I'd like to talk to you about how we can equip students to solve tomorrow's challenges today. I'd first like to start with an article that was published in the New York Times in November. Now, this graph should not be unfamiliar to you. We've seen that in the last 30 years, the percentage of bachelor's degrees granted for engineering has been steadily declining. In fact, in this article, it talks about how middle school students and high school students are the ones that are having all of the fun. They're the ones that get to play with the erector sets and get to drop eggs to validate Newton's first law of motion. It says that the students' excitement quickly dissipates once they step on campus for the first time. Now, Professor David Goldberg said we're suffering from what he calls the math and science death march. Once a student walks onto campus, they're berated with calculus, physics, and chemistry. In fact, some of the studies have actually proven that between 50 and 60% of all students who are pursuing engineering degrees decide to go on to another degree. That's almost twice the attrition rate of any other major. We need to be able to continue the excitement once that student gets onto campus and engage these students early. Now, children, at a very young age, they want to be able to build things. They want to be able to put blocks together and see the final result. We believe in practical, hands-on experiences. But it's not just about putting resistors, capacitors together on a breadboard and making LEDs blink. Students want to be able to solve today's challenges, today's relevant real-world challenges, and apply the concepts that they're learning right now. They need this to be able to prepare for the cutting-edge research that they're going to be pursuing and industry jobs. But what's needed to be able to solve these types of applications? Well, it all starts with an ecosystem. Now, Dr. Trouchard yesterday talked about one of the most popular ecosystems around today, Apple. At the very heart of this ecosystem is an operating system and tightly integrated hardware. Both are designed together. Applications are only as robust as the platform that it's built on. In fact, there's over 1 million applications that have been developed and designed for Apple products like the iPhone, the iPad, and the Mac computer. But let's take a look at an engineering ecosystem and what lies in the heart of an engineering ecosystem. We've been able to identify 6 critical elements of an engineering ecosystem. It starts with the sensors and actuators. You need to be able to take in measurements and use control I/O. Be able to do continuous acquisitions and very tight control rates from hertz to gigahertz. Once you have that data inside of your computer, you need to be able to do something with it. Analyze and math analysis libraries are important. And then you need to be able to do something and see that data, whether that's interact or visualize the data on your screen. Now, all of these different types of applications might need different approaches to be able to solve them, whether that's data flow, simulation, textual math, or C code. Each task within this system might require a different approach. And with the rapid change in technology, you need to be able to take advantage of commercial technologies like FPGAs, GPUs, and multi-core computers. And finally, you need to be able to run these applications on different targets, whether that's your laptop, your desktop, or an embedded controller. Now, you have to be able to solve all of these different types of applications in a very limited amount of time. So you need all of these elements to be compatible and instantly connectable. And that's what we call LabVIEW. It's one integrated software development environment that brings together all of these elements to meet your scientific and engineering needs. At the very heart of it, it's productive software that's tightly integrated with reconfigurable hardware. And that's the heart of our ecosystem. So let's talk a little bit about some of the different types of applications that students want to be able to solve today. Now, if you've ever been into a coffee shop that's busy, you might have run into issues actually connecting up to the internet. With so many smart devices today, the amount of data that's going through the air is increasing on a daily basis. One of the ways to be able to maximize the different types of spectrums is using what's called OFDM communication, or orthogonal frequency division multiplication. In order to implement OFDM, you have to start with a hardware platform, like the Universal Software Defined Radio, or USRP. Once you take in the data, you need to be able to do modulation and demodulation and be able to see that on your screen and interact with the data. You can use different approaches to be able to solve these types of tasks, like data flow, simulation, and even textual math, and leverage the latest wireless standards, whether that's the latest 802.11 standard or even WiMAX, and then run this on your personal computer. Now, digital communications is a very abstract course, very theory-based, a lot of equations. Robert Heath at the University of Texas has actually been able to provide a practical experience of digital communication into his courses, incorporating these technologies using LabVIEW and the USRP platform, giving students the opportunity to experience the equations and interact with the equations to get a deeper understanding of the material. Another really relevant challenge today is sustainable transportation. And I don't have to tell you if you've been to the gas pump in the last week. One of the solutions that we see on the roads today is hybrid electric vehicles, similar to a Chevy Volt. But what would it take to actually implement your own Chevy Volt? Well, there's a couple of different processes and steps that you actually have to participate in. The first one is modeling and simulation. You need to be able to create control algorithms that are going to be able to control the different types of subsystems within the car. Then you're going to need to be able to validate that using techniques similar to hardware in the loop or software in the loop. Once you have your algorithms, you're going to need to prototype them using systems like the Compact Rio embedded controller to incorporate those custom algorithms into your actual application. Visualize it with your user interface and incorporate multiple approaches to this very complex problem, like data flow, simulation, and state charts. And then actually deploy it to the vehicle. Now, there's a challenge out there right now that allows students to be able to implement sustainable transportation. EcoCar challenges 16 different universities to be able to pursue a better means for transportation. A team at Virginia Tech actually incorporated the NI platform and the NI solution, including LabVIEW, Compact Rio, and PXI. With their solution, they were able to achieve the equivalent of 82 miles per gallon using the car in 3 years. At the end of the competition in 2011, they placed first place out of the 16 teams using the NI solution. The last task that I like to talk about that students want to be able to solve and see as a very relevant problem is the grid. Now, one of the biggest challenges with the grid today is the inefficiencies of being able to manage and maintain the supply and the demand that's based on the infrastructure. It's estimated that about $150 billion are wasted every year from these inefficiencies. So what's needed to actually monitor this grid and improve it and improve these inefficiencies? Well, you need to be able to start off by monitoring the different aspects of the grid using data acquisition software. Incorporate sophisticated algorithms, whether that's signal processing or using something like the PID toolkit, and be able to visualize and see what's actually happening on that grid. You can use different approaches like data flow, incorporate the latest technology on your laptop with multi-core processors, and then be able to run it on your PC. Now, to be able to give the power of the grid to every one of your students, that might be a little bit impractical, especially with over 300,000 lines of electrical power lines going and crisscrossing across these types of grids. But we want to be able to give the power of the grid to your students. What we've done is taken the large grid and we've miniaturized it so that it fits in the size of your hand. So we have our fossil fuel plant that's being run by a motor generator, our renewable power source, which is our solar panel, that's running to our transformer, across our transmission lines, down to a city block of 3 different houses, which controls our load. So you can turn on and off different houses, monitor what's the supply of the grid itself, and then maintain the demand through algorithm development like a PID controller. And we want to be able to put the power of this grid into your hands. We encourage you to get started at your university by visiting us at our booth to get your hands on this grid using NI-MIDAC throughout the course of this conference. So please visit us in booth number 301. But it's not just about the grid. We have a number of other systems that we're currently working on and have developed to be able to investigate renewable power sources like turbines, wind turbines, or solar trackers, or even investigate different types of control algorithms with the vertical takeoff and landing. And this is part of our ecosystem. At the very beginning, I talked about ecosystems. And at the heart of the National Instruments ecosystem, it starts with LabVIEW. Being able to provide you tools so that you can focus on your designs and applications, and your students can focus on the concepts and not the tools. We want to work with you to develop and design tools that allow you to accelerate your productivity, your innovation, and your discovery. Together, National Instruments wants to partner with your university to give every single student access to solving tomorrow's challenges today. Thank you.